Hi everybody, welcome to Unit 4, Video 7. If you do not have your Unit 4 notes packet out, please go ahead and get that now. All right, so we're on Roman numeral 8. It says, I can solve word problems with fractional equations. Okay, so let's go ahead and take a look at number 1. So we have 5/16 of 4/5 of a number is 15. So we need to start by defining our let statement. So since we have of a number, we're going to say let x equal a number. All right, now we're going to go ahead and set up our equation. So we have 5/16 of, well, what operation is of? Add, subtract, multiply, or divide. Of means multiply. So of 4/5 of a number, so times x, is 15. All right, so remember, if you want to put this x, the one underneath, you can. So then we're going to go ahead and cross simplify. So we can simplify the 5 and the 5, those would both turn into 1. And the 4 and 16th, you can take a 4 out of both of them. So this would turn into a 1. Here I'd have a 4. So now that I've simplified, I can go ahead and multiply my numerator. 1 times 1 times x gives me x. On the denominator, 4 times 1 times 1 gives me 4. And it's equal to 15. So now in order to get x by itself, since I have 4 in the denominator, I can multiply 4 to both sides. So I get x equals 60. So you could say the number is 60. All right, let's go ahead and go to number 2. 30 is 20% of 30% of the number. So again, we're going to say let x equal the number. Sorry about that. Okay, so 30 equals 20%. So I'm going to write 20% as a fraction, so 20 over 100. So times 30%, so 30 over 100 of a number, so times x. So again, you go ahead and reduce your fraction. So here we know the zeros can cancel out, which would leave us with 2/10, which I can further reduce to 1/5. Here I'm going to bring down my multiplication sign. So then I can simplify 30 over 100, so that's going to give me 3/10, and then times x. And again, if you want to put the 1, that's fine. So my next step is to go ahead and multiply the numerator. So 1 times 3 times x gives me 3x. In the denominator, I have 5 times 10 times 1. So that's going to give me 50. And then I want to get the x by itself. So first I'm going to get rid of the denominator here. So I'm going to multiply 50 to both sides. So I'm going to get 1,500 equals 3x. And then to get x by itself, I'm going to divide each side by 3. So when I divide by 3, I get x equals 500. So again, we could say the number is 500. All right. Okay, so let's go ahead and go to the next problem. Pump A can unload a ship in 30 hours, and Pump B can unload it in 24 hours. Because of an approaching storm, both pumps were used. How long did they take to empty the ship? Okay, so this is what we call a work problem, and they're working together. So you're going to want to write this equation down for work problems. So work problems go like this. We say time together, so like time it takes them together. So time together divided by time it takes, we're going to say person one. It could be a ship, though. It doesn't have to be a person. It could be an object. So time together divided by time it takes person 1 plus, again, it's time together over time it takes, I'm going to say person 2, but again, it doesn't have to be a person. Person 2 equals 1. And it equals 1 because they're doing one job. Together, they're doing one job. All right, so that's the equation. Time together over time it takes person 1 plus time together over time it takes person 2 equals 1. All right, so now that we know our general equation, let's go over here and go back to the problem. So pump A can unload a ship in 30 hours. Pump B can unload it in 24 hours. Because of an approaching storm, both pumps are used. How long did they take to empty the ship? So they want to know how long it took both of them. So working together. So we're going to say let x equal time it takes together because they're both of them. So time it takes both of them together to empty the ship. All right, so pump A. So we don't know the time it takes them together, so that's X, over how long it takes pump A, well, we knew that was 30, plus time it takes pump B, we don't know that, so that's X, over how long does it take pump B, 24, because remember, this is person 2 or thing 2, and together they are doing one job. All right. So the way we do this is we want to go ahead and get rid of these fractions. And remember, in order to get rid of the fraction, we multiply by the common denominator. So we're going to multiply the numerators by the common denominator and simplify, and then we'll get rid of the fractions and we can go ahead and solve for x. So the easiest way to find the common denominator is you can multiply these two together, 30 times 24, and that would give us 720. So remember, you're going to multiply that to all the numerators, and simplify. So let's go ahead and do that. So when we distribute here, remember you're saying 720x divided by 30, but since we multiplied those together, we know when we reduce, we're going to get 24x. So plus when I distribute here and reduce, I'd get 30x equals 720. So don't forget, you have to multiply to all three of the terms. So then when we combine our like terms, we're going to get 54x equals 720. We're going to divide each side by 54. And when we simplify this, x is going to equal, so 720 divided by 54 is going to simplify to 13 1/3. All right, so now remember, since it's talking about times, we would say when they ask how long did they take to empty the ship, you could say it took them 13 hours. And remember, it's 1/3, a third of an hour. So it took them 13 hours and 20 minutes to empty the ship. All right, so remember, you get 13 1/3, so you want to reduce, or you want to put that to 13 hours and 20 minutes. Remember, you could just say 1/3 times 60, because 60 minutes are an hour, would give you your 20 minutes. All right, let's go ahead and take a look at the next problem. How much pure antifreeze must be added to 12 liters of a 40% solution of antifreeze to obtain a 60% solution? Okay, so this type of problem is what we call a mixture problem. So you might, again, want to write this down if you don't already know the formula for mixture problems. In mixture problems, we usually do in a chart. And so in our chart like this, we have, okay, so in the first category, this is usually percent of whatever you're talking about, okay? And this is usually the amount of whatever you're talking about. So like you have 5 pounds or 12 kilograms or something. So the percent of it, the amount of it, and then in this last column is you multiply them together. So we say the percent of the amount, and amount is abbreviated at AMT, of ... So it's the percent of the amount of whatever you're talking about. So again, you're just multiplying these two columns across. And then on the side of the mixture problems, it's usually like item 1, or sometimes it's like, in this case, it's antifreeze, but it could be like fruit punch or something. So I'm going to say item 1. This is item 2. And then since you're mixing it together, this is a mixture. So it's the mix. So that's the general chart for mixture problems, okay? So again, it's percent, it's the amount of whatever you're talking about, and then it's the percent of the amount. And AMT is the abbreviation for amount. On the side, it's item 1, item 2, and the mixture. Okay, so let's go ahead and take a look at our problem. Okay, so go ahead and set up your chart here. So we have our solution 1. So how much pure antifreeze must be added to 12 liters of a 40% solution of antifreeze? Okay, so in my chart, okay, so I have a couple things here. I have pure antifreeze, And then I'm going to have how much pure antifreeze must be added to 12 liters of a 40% solution of antifreeze. So this is the pure antifreeze. And then I'm just going to say just the regular antifreeze. Or you could say antifreeze 2 because it's the one. And then a mixture, they're saying. All right. And then remember, this is the percent. This is the amount. And this is the percent of amount. And I'm abbreviating that. All right. How much pure antifreeze? Well, if something is pure, it means it's 100% antifreeze. So if it's 100%, we're going to say 1 because we're thinking in terms of our percentage as a decimal. How much must we have pure? So we don't know how much. So this is X. And then, so for this column, this would be 1X or just X because I'm multiplying. How much pure antifreeze must be added to 12 liters, so of a 40% solution? So the second one was the 40% must be added to 12 liters to obtain a 60% solution. So they want to make the mixture, it needs to be 60%. So since this amount, we don't know how much pure, but we know we already have 12 of the other one. So this is going to be X plus 12. Because remember, together you're making a mixture. When you make a mixture, you add things together. Okay, but let's go ahead and fill in this percent of amount. Remember, when we go on the row, so when we go to the right, we're multiplying. So you're saying 0.40 times 12. And then in this column here, or in this row here, I have 0.60 times X plus 12. Okay, so let's go ahead and set up our equation. Since we're making this mixture, we have to say the pure antifreeze plus the other one is together going to equal the mixture. So when you do that, your equation is going to be X plus, well, I'm going to go ahead and multiply these here. So 0.40 times 12 is going to give us 4.8 is going to be equal to what I had here, 0.60 times X plus 12. And you could have distribute that if you wanted to remember. And remember, it's 0.60. So when you distribute, you're going to get, so I'm going to write this again, X plus 4.8. When I distribute, I'm going to get 0.60X plus 7.2. Now we need to go ahead and solve for X. Remember, since this is 1X and this is 0.6, I'm going to go ahead and subtract. So I'm going to subtract 0.60 to the left. I'm going to subtract 0.60x. Remember, there's a 1 here. So if you need to write that 1, write the 1. And then I'm going to subtract 4.8 to the right, so minus 4.8. So when I simplify, 1 minus 0.60 is going to give me 0.40x equals, when I do 7.2 minus 4.8, I'm going to get 2.4. And then I'm trying to get x, so I'm going to divide each side by 0.40. So when I divide by 0.40, I get x equals 6. So when they ask how much pure antifreeze must be added, you could say they must add, since we're talking about liters here, we'll say 6 liters of pure antifreeze. Okay. So let's go ahead and take a look at the second problem, or number 5 here, I should say. It says, how many gallons of cream that is 23% butterfat and milk that is 3% butterfat must a dairy farmer mix to make 30 gallons of milk that is 4% butterfat? So how many gallons of cream and milk? So those are your two things. So let's go ahead and set up the chart. So remember, we have our percent right here, percent of whatever you're talking about, the amount, and then percent of amount. Okay, so now our two things are, we have cream, so cream. Then it says how much milk, and they're making, when they mix this cream and the milk together, they make this mixture. So they're making this butterfat mixture. So we have mixture. All right. So let's go ahead and fill in our chart. So cream, the percentage we know has 23%. The milk we know is 3%, so 0.03. And they want to make a mixture that is 4%, this butterfat mixture, so it's 4%. Okay, so then they want to make 30 gallons, so the mixture has to be 30 gallons. But we don't know how much of each they have to put in. That's what we're going to solve. So one of them has to be X. So I'm just going to start with the top one. So I'm going to say if this guy's X here, together the mixture has to be 30, then the milk has to be 30 minus X. Because remember, these two, the cream and the milk together, have to add to 30. So if one of them X, the other is 30 minus X. All right, so then remember to get this last row here, you multiply across. So we say 0.23 times X. Oops. And then in my next one, I'd get 0.03 times 30 minus X. Okay, and then in my last one, I'd get 0.04 times 30. All right, so remember, you are saying the cream and the milk together make the mixture. So I want you to pause the video and go ahead and solve. Okay, so hopefully you've got X equals 1.5. And since they said how many gallons of cream must they add, so since X was cream, you would say they must add 1.5 gallons of cream. All right, let's go ahead and go to our last page here. Okay, and let's go ahead and take a look at this word problem. It says, during 60 miles of city driving, Jenna averaged 15 miles per gallon. She then drove 140 miles on an expressway and averaged 25 miles per gallon for the entire 200-mile trip. Find the average fuel consumption on the expressway. All right, so it says during 60 miles of city driving, Jenna averaged 15 miles per gallon. She then drove 140 miles on an expressway and averaged 25 miles per gallon for the entire 200-mile trip. Find the average fuel consumption on the expressway. All right, so for this type of problem, we know the relationship between rate times time equals distance, but this one we're talking about distance over rate. So you want to know that that's what you want to keep in mind here, the distance over the rate. So we're going to say distance over rate. Okay, so she did two things. Jenna, she did 60 miles of city driving, and that was her average. Then she drove 140 miles on an expressway and averaged for an entire 200-mile trip. Find the average fuel consumption on the expressway. So we're going to say let X equal average fuel consumption. I'm just going to abbreviate on expressway. Okay, so remember, we're thinking about distance over rate. So she's doing two things. So she's on the city, plus then she's on the expressway. And that's going to equal the whole trip. Okay, and we already know distance over rate. Okay, so let's go ahead and plug in what we know. So on the city, we know her distance was 60 miles. And we know her rate was 15. So 15 miles per gallon, right? Plus, on the expressway, we know her distance. She drove 140. But we don't know her average, the rate of her fuel consumption. So that's X. But we do know the whole trip. The entire trip was 200 miles. And for that, she averaged 25 miles per gallon. So here's our equation. So again, you can either start by finding the common denominator or you can simplify if you want. In this case, I would simplify. So 60 over 15, that's going to simplify to 4 over 1. Plus here, nothing can reduce, so 140 over X. And on this one, 200 divided by 25, would leave me with 8, which you can put over 1 if you wanted to. All right, so now when we find the common denominator here, it's just between 1x and 1. The common denominator is x. So remember, we're going to distribute that to all the numerators and simplify. So I'm going to go ahead and do my work over here. So in the first fraction, that's just going to leave me with 4x. In the middle ones, when I distribute the x to the numerator and denominator x would cancel out. So I'm left with plus 140. And then it's going to equal 8x. So in this case, since I'm solving for x, I'm going to subtract 4x from both sides. So I get 140 equals 4x. And then to get x all alone, I'm going to divide each side by 4. So when I divide each side by 4, I'm going to get x equals 35. So 35 equals x. And then so we would say, so since it says find the average fuel consumption on the expressway, you'd say the average, I'm going to abbreviate again, fuel consumption on the expressway is 35 miles per gallon. All right, so again, you're thinking of distance over rate. So let's go ahead and take a look at number 7 here. Because of strong headwinds, an airplane's ground speed for the first half of a 2,000 kilometer trip averaged 600 kilometers per hour. What must the ground speed be for the rest of the trip if it is to average 720 kilometers for the entire trip? All right, so this is what we're looking for. What must the ground speed be? So we're going to say let x equal, for it to x equal ground speed. All right. So we know that they are going on 2,000 kilometers, their trip, but it's talking about the ground speed for the first half. So the first half of the trip, well, if your total trip's 2,000, your first half would be 1,000 kilometers. And during that first half, they averaged 600. So that would be 600. So plus. Then we know the second half would be of a 2,000 trip would be the other 1,000 miles. And we don't know what that average is. That's what we're looking for. But they want for the rest of the trip to average 720 kilometers for the entire trip. So the entire trip is 2,000 kilometers, the distance, and that average is 720. So we need to figure out how fast they need to go the second half of the trip. So again, you might want to start by reducing the fractions and then solving. So I want you to pause the video and finish this. Okay, so let's see how you did. So hopefully you got x equals 900, and sorry for my messy handwriting, but it says the ground speed for the rest of the trip must be 900 kilometers per hour. So again, here you wanted to reduce the fractions, then the common denominator became 9x. So when you distribute it to all the numerators and simplified, you got 15x plus 9,000 equals 25. Combine like terms, solve for x. Okay, so remember, don't forget to write it as a sentence. Okay, so let's go ahead and take a look at this problem number 8 here. It says an express train travels 150 kilometers in the same time, all right, that a freight train travels in 100 kilometers. The average speed of the freight train is 20 kilometers less than that of the express train. Find the speed of each train. Okay, so the average speed of the freight train is 20 kilometers less than that of the express train. Okay, so then we're going to say let x equal average speed of express train. All right, so then x minus 20 would be the average speed of freight train. Okay, so because this is saying it's 20 kilometers less than that of the express train. So this one's a little bit different because it's the same. The time is the same. So we're going to say distance over rate is going to equal the distance over the rate. So let's start with the express train. So we know the express train goes 150 kilometers. That's the distance, but we don't know the rate. That's x. But since it's the same time, so they're going to equal, the other one only goes, the freight train travels in 100 kilometers. So they're 100 kilometers. but their average speed is x minus 20. So now that we have this, remember x minus 20 is a proportion, so it's, or I mean proportion, it's an expression, so it's in parentheses. But in this case, this is a proportion. And remember, you can solve proportions by cross multiplying, okay? So when you cross multiply here, you're going to get 150 times x minus 20 equals 100 times x. So then we need to go ahead and distribute. I'm going to do my work over here. So when you distribute, you get 150x minus, when I distribute 150, so 3,000 equals 100x. All right, so let's go ahead and we need to combine like terms. So I'm going to subtract 150x. So I get negative 3,000 equals, this would give me a negative 50x. So then you want to go ahead and divide each side by negative 50. So when you divide by negative 50, I'm left with 60 equals x. So since it says find the speed of each train, and x stood for the express train, so then you could say the average speed of the express train is 60, and we're talking about kilometers per hour. And the freight train average speed is, well, 60 minus 20 is 40 kilometers per hour. Okay, so the express train was 60 kilometers per hour, and the freight train is 40 kilometers per hour. All right, let's go ahead and take a look at the last problem. So we have Bonnie can complete her route in 45 minutes. When her sister Jean helps her, it takes them 18 minutes to complete the route. How long would it take Jean alone? All right, so this is a work problem. So remember, work, time together over person 1 plus time together over person 2 equals 1. So it's saying how long would it take Jean alone? So let x equal time it would take Jean alone. So we're going to have 18. So together it takes them 18 minutes. So Bonnie can do this in 45 minutes. So we have 45 plus we have together they do it in 18. And with Jean, we don't know how long it takes her. So she's X, but together they do one job. All right, so again, if you can reduce the fraction, you might want to reduce the fraction. So 18 and 45, you can take a 9 out of both of those. So when you do that, you're left with 2/5 plus 18 over x equals 1. So then again, we want to go ahead and find the common denominator. So the common denominator here is 5x. So when you distribute that 5x to all the terms, you're going to be left with 2x. Plus here, 18 times 45 is going to give us 90. Equals 5x. So then we're going to subtract 2x from both sides. We're going to get 90 equals 3x. We're going to divide each side by 3. So then when you divide by 3, I'm going to go over here. So x equals 30. So then it would say it would take Jean 30 minutes All right, so you could just say it would take Jean 30 minutes or 30 minutes to work alone. So, or it would take Jean 30 minutes to complete her task. All right, everybody, thank you for watching the video.